Hi friends, this is Purushottam and today I welcome you on this session on triangles. So before starting the session we will just take a quick look at what is the agenda. So first we will go through the introduction to triangles, congruence and similarity, then we talk about similar figures and then similarity of triangles. Okay, so what is a triangle? We all know that it is consisting of two words, that is tri and angle. So tri actually here refers to three, and angles you already know, the area between two sides or two arms which is measured in terms of degrees. Okay, so triangle has three sides, three angles and three vertices, which you actually know. So we will skip this discussion and we will go to congruency and similarity. So congruency also you have already studied in your earlier classes, but still we will take a quick recap. That is, congruency means when two figures are identical in shape and size both. That means when two objects completely superimpose on each other. So we have several examples we know, that is our footprints if you say, and some clothes which are of the same size, they also like superimpose on each other, and pack of cards, and there are so many objects you see which will superimpose on each other, so they are all congruent. Okay, so in this session we will not talk much about congruency, we will limit our discussion only till similarity. Okay, so take a quick look at this picture. So this picture belongs to the same person at different ages. Okay, maybe when he was a child, then a teenager, then youth, and when he has grown to a middle age. Okay, so what do you observe here? That all these pictures they have two things. One is the shape and next is the size. So what do you comment on the shape? The shape is different, right? We can clearly see, but the size of the photo is same. So does this fulfill the criteria for similarity? No. Actually for similarity, the object should be of the same shape, but their sizes may differ. Now we go to the next example. Okay, here we see it is a photo of the same person, like we have the stamp size, passport size and postcard size photo of the same person. So does this fulfill this criterion for similarity? So we have here the shape and size, so we clearly see the size is different and shape is same, so it fulfills the criterion clearly, and yes, it is a similar object. Okay, now in this session we will particularly talk about the similarity of triangles. Okay, so when we say that two triangles are similar, actually when two figures or two triangles, when they are of the same shape but different size, which we have already seen earlier also, and it applies to triangles also. How does it apply? We'll just take a quick look. So now we are going to do one activity to understand the similarity of triangles in a more better way. So here we take a cardboard which is triangular in shape, and we place the cardboard parallel to the ground. Okay, and what we will do, we will take a light source and we will put the light source at different positions. Okay, let's say we put the light source at position 1, then again we do some calculations, then again we put the light source to position 2 and do calculations like that. So in all the cases, friends, you see that there will be two triangles. So one is the cardboard and another one is the shadow, right? So this is how we are going to do the activity. So in the first case, yeah, so we have this, I will just show you here that we have this light source here, and this is the cardboard, and here we have the shadow. So in this case what we see, that the shadow is a straight line here. Okay, so there is nothing to calculate. We will just calculate the dimensions of the cardboard, like the sides A, B, B, C and CA, and the angles, angle A, angle B and angle C, and then we proceed further. So we go for the case 2. So this is a case 2 where we have put the light at a certain angle, okay, and it's like a tilted angle, not exactly on top of the cardboard but at a certain angle, and then we get the shadow as A dash, B dash and C dash. So this is what we have got. So what we will do here, the shadow dimensions we are going to calculate, that is angle A, angle B and angle C, C dash, angle A dash and angle B dash of the shadow, and the dimensions or the sides of the shadow, that is A dash, B dash, B dash, C dash and A dash, C dash. Okay, so we keep this measurements at one side and again we proceed. So in this case, you might have guessed it right, the light is exactly on the top of the cardboard, so the shadow again falls on the ZX plane here. So this is the case again. Similarly as what you did in case 2, you calculate all the dimensions and including the angles of the shadow, and after all our calculations and measurements are over, then we come to a conclusion that in case 3, when the light is exactly on the top of the object, these ratios are equal. Okay, that is AB divided by A dash B dash is equal to BC divided by B dash C dash is equal to CA divided by C dash A dash, and even their corresponding angles are also equal as we have shown here. So friends, we have seen 3 cases, right? That is when light was put exactly when the shadow was a straight line, and then at a certain angle and exactly on the top. So in all these 3 cases, in the third case only we see that the 2 triangles are similar. In other cases we see that their angles are not matching or the sides are not so proportional, but in the third case when the light is exactly on the top, these 2 triangles are similar. Okay, that is their angles are equal and their corresponding sides are in the same proportion. So we will now learn about the different criterions for similarity and Pythagoras theorem in the next video. Thank you so much.